Hello, class. Today's review is Wednesday review. 7 more questions. A few of them are short, and one or two of them are have some work to do. So, number one, the points at the graph changes direction, increasing or decreasing. Of course, are the turning points. The second one, use the remainder theorem to find the remainder when f of x is divided by x minus 1/8. So it says to use the factor theorem. So what we're going to do using the remainder theorem is we plug in 1/8. So f of 1/8 is, and you can plug it in this formula. You can do it with your calculator. I did it by hand. It wasn't too hard to do by hand. It ended up being 1/8 cubed. I didn't cube the eights. Minus 1/8 cubed, which zeroes out. Minus 16/8, which is 2. -2 plus 2. So that is 0. So the remainder theorem states that C is a factor if f of C is equal to 0. So yes, it is a factor. So you just plug it in and check it. If the remainder is 0, then the answer is yes. Okay, number 3, information is given about a polynomial f of x whose coefficients are real numbers. So to find the remaining zeros, I believe everybody should find the same thing with degree 3. They give you a real root and they give you a complex root. So of course the other root is the conjugate to the complex they give you. So just change the sign in front of the imaginary part, and that is your other root. Okay, number 4 says find the domain. So just check when the domain is equal to 0. So x cannot equal to -20 because otherwise you get it undefined. I think that's it on that one. Okay, number 5, the longest question. The first thing is, what is the domain of r of x? So what I did is I took 4x squared minus 3x plus 73, and I factored it, and I found that these two were my factors, 7 and 9/4. You can also type it in the calculator. The only problem is you would only type the denominator and look for the zeros. The second part says, what is the equation of the asymptotes? Well, you think it's both of these because they're both candidates. But what you can miss if you don't look at it is the numerator. If it also has the same factor, then you have a hole in your function instead of an asymptote. So looking at this, you can do the same thing. Put it in y equals just the numerator, and you'll see that it also has a 0 at 9/4. So since it's 9/4 gives you 0 over 0, that is not an asymptote, it's just a hole. So then 7 remains. Okay, and then it says, what is the horizontal or oblique asymptote? That's when you look at the degrees. I see that they're both squares, so they have the same order. So it's going to have a horizontal asymptote. And since they're the same order, then the asymptote is going to be 28/4, which happens to be 7 again. If you have 1 degree higher in your numerator, it will be an oblique asymptote. And you divide to find out what it is. If you have 2 degrees higher in your numerator, then you have no horizontal nor oblique asymptotes. So you can only have either a horizontal or an oblique. You can't have both. Now you can have more than one vertical though. Okay, and then the next thing is to find the graph. So what you can do is you can, since I know the asymptotes, the dotted line should be at x equals 7 and y equals 7, so I just picked it out. Or you can graph it on your calculator. Okay. When you solve the inequality for x to the fourth is greater than 16, I have to remember that negative values are also positive when you raise them to the fourth power. So this means if I had negative 5 to the fourth is definitely greater than 16. So the turning point here is at 2. So anything with the absolute value greater than 2 is the solution. And so in interval notation, you start at negative infinity to negative 2. You do the union and then continue with 2 to infinity. And that's the solution to this inequality. If you have anything between the twos, like say x is 2, then it would be equal, and it doesn't stand true for this inequality. If you had 1, it wouldn't work. If you had 0, it wouldn't work. So that's why you have this gap in the middle of your solution. Okay, the last one is one you've seen before, given two functions, f and g. It looks like fog. That's your composite function, and it's defined as f of g of x. All right, that's it for today. Have a good rest of your day, and see you tomorrow.